So let's resume these examples. So we just completed or solved or found the domain of that f of x function up there. So if you missed that video and you're interested in that, go back and watch that video. For the second one, now we are going to focus on finding the domain of that g of x function. Now g of x is different from f of x in that it's going to give us a different output. It's going to work just a bit different. Well, the steps are going to be the same, but you will see why you would get a different domain. The way our domain is going to look is going to be a bit different. Again, I left this in red up here. When we're finding our domain, I like to ask ourselves what numbers are not part of the domain. In other words, what numbers can I not? This is for a rational function, okay? So what we want to do is we want to look at this rational function. We want to look at our domain or our denominator. We want to ask ourselves, what values can we not substitute into that denominator? I'm not looking at my numerator. I don't really care what I substitute into that numerator. Not just yet. Later on, it's going to be a bit complicated, but right now, a bit more complicated or detailed. I won't say complicated. But right now, I'm just concerned with that denominator. So I know with rational functions or with fractions, however you want to label them, that my denominator, it cannot be equal to 0. So I can substitute any value in there as long as my denominator does not equal 0. When it equals 0, that's when I have a problem. So that's the numbers I want to look for. So let's solve for x. You want to take that denominator, set it equal to 0, and solve for x. So we want to bring that 9 across. So that's going to give me x squared is equal to 9. Well, unlike the last problem, f of x, when I got to this step, this time my x squared is equal to a positive number. So that means there is some number that when I square it, it's going to be equal to 9. So I'm going to take the square root of both sides. Remember, when you take the square root of 9, that leaves you with two numbers. That's going to be a positive and negative 3. So my domain, and I want to stop. That's one way of getting the answer. So that's one way. How do I get this answer a different way? Well, that x squared minus 9, I want to make sure, and I don't know why I didn't do it this way. This is an example of how we can work math problems many different ways. But this is what we call a difference of squares. Meaning this x squared is a perfect squared. This 9 is a perfect squared. And the difference comes from that minus there in the middle. The difference, a difference of squares. So there, you can factor this. You can solve this by factoring. And the way we do that is by taking the square root of that first term. The square root of x squared is just x. The square root of 9 is 3. Well, if I do it like I did up top, the square root of 3 is actually, the square root of 9 is actually a positive 3 and a negative 3. So either way we work this out, if I were to finish solving this down here where it is in factored form, what would end up having, I would end up having x is equal to negative 3 and x is equal to positive 3. So this is my second way to solve this. So it doesn't matter which way you work it out, you're going to see that I cannot substitute 3 and negative 3 into that denominator. Why? Because if I did, my denominator would be equal to 0, and we can't have 0 in our denominator. That rational expression would be undefined. So let's scroll over. How do I represent the fact that my domain consists of all numbers except for negative 3 and 3? Well, in interval notation, I would write that by saying that I'm starting at negative infinity. And let me erase this just a minute. Some students have trouble with this. So I was working with a student last week, and I suggested that you plot these numbers on a number line. And it doesn't have to be precise. I just want you to plot them in order and kind of place them where you think they might be. So on a number line, I know that -3 would be here somewhere and +3 would be there somewhere. And I cannot include those numbers. So what you would want to do is for each one of these intervals on that number line, you want to represent them in interval notation. So for this first part of my number line, I would represent that as from -infinity to -3. And I put parentheses there because I can't include -3. Later on, I might be able to include that point for one reason or another, right? But right now I can't. That -3 causes trouble. It gives me an issue, so I can't include it. So I put that parentheses there. So let's change my color. This middle part here begins at -3 and it goes to +3. And again, I put parentheses because I can use every number there except for -3 and 3. I cannot include those endpoints. And the last piece here of my number line will begin at 3 and it goes for infinity. So that's going to be +infinity. So that's my interval notation. The only thing that's left is unions. We have what's called a union, and I will write this a little bit prettier for us. The union is kind of like it connects it. We're going to say it's kind of like our and statement. It's -3 and 3, union 3, 8. So technically what that is saying is that I can use any value between -infinity and -3, or I can use a value from -3 and 3, or from 3 to infinity. But any of those values, all of those x values is part of the domain of f of g of x. I hope this helps.